All right. Hello, everyone, and thank you for joining us for this latest installment of Luna's live webinar series, Automated Hydrocarbon Extraction, Your Competitive Advantage. My name is Joe Goodman, and I am the Sales Engineering Director here at Luna Technologies. Joining us today is Jack Nato, President, and Kyla Buck, Process Development Director, as well as Adam Hain with Technical Sales. So today's webinar will be an inside look at the benefits of automating your hydrocarbon extraction equipment with a special focus on the wide range of production problems involved high and your business competitive. So first up, co-founders Kyla Buck and Jack Nato, will recount the company's founding, looking back at, how necessity fueled the design of the fully automated IO extractor, facing common production problems in his own business. Kyla looked to automation to maintain profitability. So then we'll give you a closer look at the IO's control panel, a user-friendly HMI, which puts the extraction process at your fingertips. And afterwards, Kyla and Jack will stick around for a live Q&A and ready to answer any and all questions that come in. So I've posted links in the chat-in area with our contact info, website, as well as links to follow us on social, and a recording will be made available to everyone here via email for future reference. So I'm going to pass it over to Jack, and we'll get you guys introduced.
For that. I'm Jack Nato, one of the co-founders of Luna Technologies and its current president.
And I'm Kyla Buck, also one of the co-founders, and now with the role of process and product development.
Awesome. Well, thanks, guys. Obviously, happy to have you here. I'm going to kick it off with Kyla. I just want to ask you guys a question here and kind of go through the story a little bit about how Luna got founded. So, Kyla, I know you've been in the industry
around that, and especially with, you as growing, you focus so long on, getting that process it, and actually get a higher return, on that oil than it would have been as flour anyways, and eliminated all of the hard work and labor that came along with harvesting. So, I started with some off-the-shelf equipment and quickly realized, some of the lack to fulfill my needs and, the pain of labor that caused me to then pursue the equipment side and building the equipment to get me to where I wanted to be.
And Kyler's underselling it a little bit. It was a huge challenge for him running all that manually operated equipment.
Yes, well, as I, grew, once rec happens and, we started to realize that all the equipment out there, at that time, 2012 to, really 2016, when we came online and offered that automated technology, just the equipment parts out there were really marketed and made for, that medical small processor scale, more of like a lab scale, and it was really nothing really engineered or purpose built for extraction at the time. It was all repurposed brewery parts, and even still today, a lot of our competitors, you compare, the extraction equipment and what it looks like, and it's really just a tube out of a brewery equipment, with a little bit beefed up to hold the pressure rating.
Awesome. Hey, thanks, Kyler. I got a question for Jack, obviously. Coming from Boeing, what originally got you excited about working in the cannabis industry?
A lot of what Kyler was just talking about. The cannabis industry is still really new. All the equipment that was out there in 2016 or even back to 2012, it wasn't really designed for extraction. So there was just a lot of freedom to engineer different, to solve a lot of problems in the space. Where in aerospace, lots of the product development happens over years or sometimes even over decades. But here at Luna, we can have a design concept and get it to like a retail product in a matter of months. and it's something completely new that no one's seen, which is a lot harder to do in what I was doing before.
Well, I'll add in a little bit to that story. At the time when Jack was still working for Boeing, I invited him out here to take a look at what I was doing, and he kind of looked at the equipment in shock and, asked, how much is oil worth? And this is the equipment you're doing it on? And, that with his ability and talents and...
I mean, that's such a great story. So, obviously kind of shifting gear, Kyle, what kind of equipment did you have experience with prior to, Luna coming?
Yeah, as I briefly talked about before, down and, pass through that biomass, and that's how all of the closed roots extractors were in 2012, and they progressed, but really not quick enough to keep up with the industry, and especially when you think of, any other industry and how vital and important automation is to those processes, from cars to food processing. Everything is done automated, and the reason for that is the consistency and the ability to maintain and grow. And, that's really the start of Lunatech, was realizing that lack in the industry and, trying to build a higher quality, purpose-built machine that will be able to pump out that consistent product.
Yeah, totally. And that's obviously what our machine accomplished. And I mean, Jack, coming from a different industry, was there much overlap with what you were doing previously with Boeing?
There was, yeah. I mean, really everyone, what I was working on there was trying to solve similar problems in that we had a really labor-intensive process that we were trying to automate, because when you have manual labor, there's just a lot of room for human error. And, when you're putting together a wing skin for an airplane, if you make one small mistake and don't catch it, it could cost you, or cost the company, millions of dollars. And it's similar to cannabis, where if you make one mistake by turning a valve at the wrong time or setting your chillers at the wrong temperature, you can easily blow a whole batch, which could be, tens of thousands of dollars in minutes.
So that's obviously, the risk of screw up, but then also the savings it gives you on the labor you're using today. I mean, before Jack, I was spending tens of thousands of dollars on cooling with dry ice or, liquid CO2. The ability to automate the process and use the chillers and use electricity for cooling, and all the other efficiencies that come with, the properly sized heat exchanger for recovery.
Yeah, some of the most fun stuff was just, when we first came in and started doing this 5 years ago, there was so much low-hanging fruit that it was just really easy to go after. And then after a year or so, then we started working on some of the harder problems, and it's a different type of challenge that's, both are really fun.
So, Jack, what were some of the biggest pain points while designing the equipment?
I think a lot of it is just going back to like a blank page design. We really tried to, instead of looking at equipment that was on the market and say, how could we make this a little bit better? And we had this problem, like, what would we do? Like, how do we do it right, and how do we do it the best way from the start? And I think that helped us a lot. Like, I'm trying to think of an example. Something really simple, like originally BHO extraction, the collection pots were all a big giant pot, and at the end of the process you'd have your product in the pot and you'd pick up this potentially 50-pound thing, carry it over to your tray for the oil out. And the minor improvements that most people were making were like, let's put handles on the pot, or like, let's make the handles a little bit better. But we just said, let's raise it all up and put a valve under it and a tray under the valve, so you can turn a valve instead of carrying around this 50-pound thing.
Yeah, the floor surface. It was crazy. It made our job easier.
Yeah.
So, I guess, Kyle, you kind of touched base on this a little bit, but, what were some of the biggest challenges you were running into while running manual equipment, like labor rate, turnover, et cetera?
Oh, yeah. the labor rate and just, I mean, being able to find that extractor where I was actually comfortable enough leaving him on this process was hard. I mean, again, like some of the huge improvements too is like the consistency of product. With the Lunatech, you know, as an extractor, my consistency had gone so up so much. And one of my favorite examples of how we're different is the viscosity selector on our product. I mean, when you think about how popular and important diamonds and sauce is to the industry right now, and being able to consistently leave the same amount of solvent as you pour, which is crucial to the THC crashing out and, you know, creating that terpene layer. And then obviously the dry ice and the expenses that I had and not using the appropriate, you know, chiller and really designed, packaged, and, you know, for cannabis fresh frozen extraction.
Great. So we got one more question you guys both can answer, but how did you guys end up landing on automated extractor?
I think it's kind of just all the reasons we've been talking about. I mean, it was the only, we were looking at the problems Kyler was facing every day running an extraction business, and specifically around the equipment. And the only answer to all those problems was to automate the extraction process.
Extractor, you have this high, you know, labor skilled trained guy that if he doesn't show up, you know, you're kind of screwed over. Production's down for the day. With automation, you know, we have our extractors, but really we can pull, if that extractor is sick or doesn't show up for the day, I can take a packager out of the assembly line.
All right, I'm going to shift gears a little bit, Joe. I'm going to pull up, bring us into it. What were the connection issues? All right, well, someone just flag us if you can't hear. All right, we're going to talk about automated hydrocarbon extraction. I pulled this first slide up just because these are the 3 points that Joe kind of mentioned earlier, that the 3 categories we're going to tie this all into: quality, labor, safety. This is all what we've already been talking about. And this slide is just showing that here's all the points we'll be going over. Everything is interrelated. None of this just falls into only quality or only labor savings or only safety. There's a lot of overlap, so just keep that in mind as we're walking through this. We're also going to look at, we're going to start with problems that we've experienced either in Kyle's own lab or in other extraction labs. We've got a lot of experience. We've seen a lot of different extraction labs around the country and around North America. So we're going to look at the problem and then how we chose to solve it with automation. First one we're going to talk about, which is really important to me, and I think everyone in this industry, is hazardous materials. We all know that every extraction process uses exposes operators to some sort of hazard. With CO2, you have extremely high pressures, and then with BHO, you have, well, by the name, you have butane or propane. And there are a few reasons why we have to use those. Kyler, do you want to get into why butane and propane are so important?
Yeah, what makes butane and propane slightly more dangerous to operate with also gives it its best benefit, and that's terpene retention in your product. If you think about it, butane, propane, it evaporates at room temperature, has a very low boiling point, and that makes you able to pull 100% of the solvent out of the product before stripping any terpenes or anything else like that. CO2, is all that high pressure, it will actually, degrade those terpenes as it's pulling out. That's why if you ever smell, pure CO2 terpenes, it's really nothing like the plant. And then ethanol has such a similar boiling point to terpenes that to pull all of the ethanol out, you're stripping the terpenes too. That's why if you go into dispensaries today, all of the high quality products are BHO products. And really you can't do live resin with any of those other solvents. With CO2, you can't put fresh frozen into their column because it basically is a pipe bomb at that point. And that's why they tell you have to dry your material out bone dry, which is ruining that biomass for the terpenes. And then ethanol, you also don't want to extract fresh frozen material because you end up with all of that water in the ethanol that is really hard to separate after the fact. And even then with that, the terpenes in the ethanol stay together. So the boiling points are so similar that by stripping and pulling that solvent out of the oil, you're being able to pull all of that solvent out of there to 0 parts per million before pulling any of those valuable terpenes.
Yeah. So the volatility is necessary, but it's also our biggest hazard. And that's why we wanted to focus on it. So if you look, this is a clip from our installation drawings. And this area in the center, this is your extraction room right here. And that's all your potentially explosive environment. And then you have a little bit on the outside that's also around the door where things could seep out. So looking at how you solve that problem or lower that risk, we looked at, this is OSHA's hierarchy of controls. This is the different methods that OSHA suggests you should engineer around different hazards. And at the bottom of the list, you have the least effective methods, and at the top of the list, you have the most effective methods. So if you're looking at manually operated systems, you're really stuck at the bottom, either with PPE, that's personal protective equipment. We've all heard that term 1,000 times now. And it's really, really not effective against a potentially explosive atmosphere. And then slightly above that, you have administrative controls. That's things like with a BHO extractor, really good training for your operators, and then repeating that training over and over again, or things like splitting your shifts up so you only have operators actually extracting for, say, 2 hours a day, so that you make sure they're really attentive and have a high, they don't burn out, there's no fatigue, which can cause
error.
Yeah, exactly, error and safety risk. Then above that, well, at the top of the list, which we kind of already went over, is elimination and substitution. These are really, in most cases, in engineering around safety issues, these are just kind of off the table. And we kind of went over why that's not on the table for this. We have to use butane and propane. That's how you get these live resin products. So then we fall down to engineering controls. And engineering controls are used to isolate people from the risk. And automation it's an easy answer to that. Like if the dangerous area is in the room right here, and you get your operators outside standing right here and running the equipment from our control panel, then you've isolated them from the risk. So typically, if you're running our equipment, you are in the extraction room for maybe 5 to 10 minutes per hour. Whereas with manual equipment, you have at least 1, maybe 2 operators who are in the room with the equipment pretty much full time, right?
And one of the benefits of our equipment too is it actually ties in to that alarm monitor that monitors the gases. So it will actually shut down and isolate all of the vessels if there even was a leak. So our system, it minimizes the risk even when they're in there as well.
Yeah, exactly. Yeah.
And we're one of the only systems available on the market that can actually tie in to that alarm and shut down operation once it senses gas.
Yeah, which is really surprising because actually, per the new NFPA code, everything inside your extraction booth, any electrical, has to be tied into the gas monitoring system now on an interlock. Anyway, our system is, which is a important safety feature. But yeah, the biggest by far, the biggest thing we can do for safety is get operators outside of the extraction room. Mm-hmm. And so we try to, through remote control and through our panel operation outside the room, we try to move them away. I think, Kyler, this is a problem that you are best suited to talk about, because it's just all about how operators have to, how attentive they have to be, and the risk of error in operating that equipment.
Well, yeah, so if you look at this slide, you can see all of the circles, and those are all either points of pressure that you're monitoring and reading manually. We're on.
There we go.
Okay, so sorry about the technical difficulties there, having a little bit of a camera and audio issue. But back to this PowerPoint, if you're looking at the machine, you see all the circles. The red is the actual valves, which the operator, whether it's, the recipes on a time schedule, has to memorize the recipe and independently operate all of those valves to get the movement, and the inputs, what you are constantly checking on the blue valves. Our system monitors all of those pressure points and ball valves at 100 times a second, which enables it to safely maintain all of those pressures and get consistent flow through the system. Really, with these systems, these manual operated system, it takes a very skilled, high wage employee to accurately run all of that.
Yeah, and you had issues with high wage employees who you would train to operate your equipment, right?
Mm-hmm. Yeah, I mean, a lot of the times too, now they're in control. They now feel like they're the most important person in the company processing this oil, but then also have this skilled trade labor that, I've had lots of guys get poached by other companies and, offer more. And then I'm not in a position to bargain with them once they're taught fully how to.
Yeah, you've trained them, and then some other company benefits from your training.
Yes.
Yeah.
Or I've had employees leave and start their own extraction operation too.
Yeah. So here's how we do process control. This is the home screen of our HMI. On the last screen you saw, there's about somewhere between 16 and 20 valves that operators would be turning. So you have 16 points of control where your operators are in there affecting the system. With us, it's pretty much one point of control. It's the start button on the right side of the screen. So really, yeah, you're pressing the start button and walking away. And then instead of walking around the equipment and looking at, 20 different points of data like pressures and temperatures or sight glasses, we have it all in one screen. So if you want to monitor the process, you can do it sitting in front of your touch screen. So for example, let me pull up a pen. We have level sensing right over here, so you can tell how full your solvent tanks are. And then we have pressure and temperature on all the vessels. And then we also have liquid level in our reactor vessel. We also have all the valve statuses are constantly being monitored, and they'll give you feedback. So you can see over here on the left side, this valve is open one direction, and it's going to show you what the flow path is for that valve. So you can see that liquid can flow in that direction. And then this valve over here, or all the other valves on the screen, are closed, and so that there's no flow right here. So it's just a really quick way. You can look at this one screen, have a good idea of everything that's going on with your system without needing to walk around the equipment, and then, picture in your mind where, I open valve 6 on the equipment. What is that connected to? Okay, let me trace it in my head. Let me trace it on a physical piece of equipment. On this screen, it's all sitting right in front of you. We also have feedback for all of our pumps, so you can see when pumps are running. You can see when the chillers are turned on and what the temperature of those are. It just really puts all the control in one place. And again, this is all just optional monitoring. You don't need to be looking at the screen. Really, hopefully, most of our customers are just, they're pressing the start button and walking away.
And a nice thing too is if you fill them in about where they are in the process.
Oh yeah. So on this right side, you can see, you're going to get some more information like, here's the current run number that you're on. So if you process 16 runs during the day, you're on run 16. Here's the name of the recipe that you're running. We can show you the recipe screen a little later. And then here are your run counters. So you're 0 minutes into run number 0. And eventually when this system is operating, these boxes down here are going to light up. So you can see, okay, the system is currently filling. Then you can go look at your screen and say, okay, I see that the fill valve is opening at the right time. It's filling the system, and it's filled the reactor because they're at the high level light is on. So it just makes, if you do want to manually operate the equipment for some reason, it makes it a lot easier to do so. You can do it all from this screen. All these buttons are they're interactive. So if you click on this valve, it'll pop up a little message and you can manually open it or close it.
Another cool thing too is all the data logging. So everything Jack just showed you is all logged, and it's logged to the extractor that it's using it. So you can see how many runs Jack got done through his day and how many runs Kyler got on his shift.
Yeah. And we'll pull up a whole screen on data logging. Okay. Kyler's talked a lot about inconsistent product and how when you have manually operated systems, an operator can maybe not make a mistake. I mean, I wouldn't necessarily call it a mistake. We have human error on the slide, but really it's like, okay, I opened this valve 2 minutes late and it created a significant problem. And we don't really know why. So with pre-programmed recipes, clearly that isn't really an issue. Everything is run by a computer system. You have full control of what that program is. So if you look over on the left side, here's our recipe editor. Let me get that. And you can see you just input your soak time. I want to soak, let's say, 2 times for 15 minutes each. Here's my solvent tank temperature. Here's my soak temp. I'm going to do 2 soaks, and then I'm going to drain for an extra 6 minutes. So it's all pre-programmed. You can create these on your computer. You can create them on the touch screen. You can lock your operators out of these recipes so they can't so they don't know what they are, or so they can't edit them. And we can store up to it's some crazy amount that you'd never use. Like we can store 1,000 recipes or more. Really, a good 10 to 15 recipes is enough. But yeah, getting rid of that inconsistency.
Yeah, if you want to do multiple soaks, or if you're running fresh frozen, dry material, CBD, shatter versus sugar, those are all slightly different recipes. And really what's enabled us to customize those beyond any other system on that market is viscosity selector, which I talked about before too, which is on the screen here. Jack will circle you this end run viscosity. And that allows you, if you're running shatter, you want to pour really thick onto a piece of parchment and have as little solvent as there possible. So you just got that muffin flat on the parchment paper that's ready to stick in the oven. For sugar, you want to leave a little bit more solvent in to get that sugar consistency, because that happens after the fact, after it's out of the machine, but we're still able to control it by selecting how much solvent we leave in. So we know, pour it into a Pyrex, it's going to sugar out in the oven. And we go beyond that with the sauce and diamonds. We leave even more solvent in with the appropriate amount of solvent that if you put that in a jar, or if you put that into, your pressurized diamond miner, it's going to crash out consistently every time.
Yeah, and I know when I first came back to work with you, I was running manually operated equipment and you were teaching me how to do that. And I know the hardest thing to learn was when to stop the run.
Yeah.
Because I'd often stop it too late, and really that would be the difference. We wanted to make shatter. I ran the run too long, or ran it a little, or not long enough, and then we couldn't make that. It was impossible.
Yeah. Well, yeah, you just have finicky, you have nucleation in your slabs, all of that. we've really dialed that in and taken the possibility of air out of the system. And that's really, why the term extract artist came into happen with how, finicky some of these processes are, which is why it's so important to automate them and get it the same consistency every time.
Yeah. All right, the next problem we're looking at is the higher amount of labor time that is needed to run manual equipment. I think we've touched on this a lot already, but I just wanted to lay out an actual extraction lab to just give you an idea, or have Kyler give you an idea maybe of what your operators can be doing instead of running the equipment their full time. So here on this screen, you can see, just give you a quick, here's our C1D1 booth. That's where the extractor sits. Here we have some post-processing tables, maybe with some lab equipment on them. Here we have our vacuum ovens, material storage. So there's just a lot that your operators can be doing when they're only spending 5 or 10 minutes an hour on the actual extraction process.
Yeah, the beauty of our equipment is, like you just said, the operator's only operating at 5 to 10 minutes out of every hour. That allows one single extractor per shift to not only run and operate the equipment and process 200 pounds in a shift, but he can pack his own columns, unpack his own columns. We have an automated packer if you even want to eliminate that. But running the ovens, doing all of the post-processing, flipping slabs, whipping butter, really all of those components a single operator can control. And that's what we've realized is, so important in this industry is how competitive it's getting. It's all about, your operating cost, and minimizing your operating costs is going to be what allows you to succeed and survive in this growing competitive industry.
Kyler talked about data logging a little bit earlier. I think there are a lot of benefits of data logging that aren't explored. So we just laid them all out right here. The first big one that comes to my mind always is compliance. GMP is not required. There are no requirements for GMP requirements in the US for cannabis extraction, but there will be. We're already starting to see it come into Canada and definitely in Europe. And GMP is going to require you to log data for any recipe you're running. That's just, it's set in stone. There's no way around that. Then another big issue, if you're running a manual system or if you're just not running data logging, is if you're trying to work on process development, trying to improve your recipes, it's really hard to do that with handwritten data. We actually tried to do this a lot early on. Like, we were trying to build the best recipes for Kyler's business, and it's just hard when you have a guy sitting there writing down, taking notes. Okay, the temperature at this time was -20, temperature this time was -30. I opened the valve at this time. It just doesn't really work. And inconsistent data is really not a help to anyone. You can see over on the right side of this screen is our data logging screen. We log pretty much everything the extractor is doing, all our valve positions, any emergency stops or any operator input. So if any of your techs throw a valve into manual mode, you'll see that, and then you can go and ask them, hey, why are you taking it out of the automated recipe? And then, of course, we measure and record all our pressures and temperatures, which you can see on this trend screen. It also makes it really nice for management oversight. Like Kyler was saying earlier, you can go back and see, okay, Jack was logged in and the run ended, and then half an hour went by before the next run started. You can go back and Kyler could talk to me and ask me, what was I doing for that time? The equipment was just sitting idle, not producing any product.
Yeah, so as, an oversight and management for, your lab manager or the business owner, being able to log in at any time, see what your extractors are doing on the equipment, what run they're on, And, back to what Jack said, the inefficiencies, you can compare, why did Kyler get 8 runs and Jack did 4? It will show you that the run had ended and it took Jack 30 minutes to load the next column and replace it and hit start, and it took me 2. All of that is just so important for the business, and, being able to properly run a lab and maximize all of your efficiencies.
Yeah. Another big issue is that every extraction, every business that operates equipment runs into is just unpredictable downtime. Things break or things get tired and you have to replace them or repair them. So a solution that we've started working on through automation is predictive maintenance. So what we want to do is, what we are doing is measuring the actual amount of time that your pumps are running. Let's measure the actual number of times that your valves are being opened and closed. So then we can go back and compare it, one, to just the manufacturer's data sheets first and say, okay, this pump is a 1,000-hour rebuild schedule. Let's pop up some messages on your HMI so your operators know, okay, I've got 100 hours to go until I need to rebuild this pump. Another message at 50 hours, another message at 20, another message at 0, to make sure you can plan ahead for that maintenance, so you don't just come in one day and your pump doesn't run and then you say, oh, I forgot to rebuild it. Same with valve cycles, and same with, for us, it's really nice on our molecular sieves, which have to be regenerated. They dry the gas out in the system. So it's just popping up every number of hours that the sieves are actually being used, reminding you to
on
replace.
That note, and just how important it is, those of you who have been extracting or even new extracting, moisture could be one of your biggest problems, causing ice buildup and ice clogs can be one of your biggest problems running. So having that tracked and having it known and the machine tell you, okay, it is time to change the multi cartridge and replace it, is really huge for that day-to-day running and making sure you're up and running 24/7, 7 days a week.
Yeah. And then going back to data logging, if we're collecting data this whole time, we can then go back and say, okay, this pump, maybe we have to replace it. Maybe we're in a harsh environment. Maybe you're by the ocean and have salt water in the air, and you find out that our pump keeps failing at 750 hours. Now we're just going to reset that and adjust our recipes or our warnings to remind you, to predict when you have to do that maintenance, to make sure you don't have downtime.
Which we haven't had, by the way. The MVP has actually been a very reliable pump. And, suggested by them every 1,000 hours is a gasket you change. But we see operators running 1,500 hours,
Oh, probably
all the time.
Over 3,000.
Yeah.
It's a reminder, and it's best to follow the maintenance schedule. So
yes,
and is a good way to stay on top of it. Another huge benefit that I don't know if we went into this trying to solve this problem, but it has been a huge help. I know for our customers and for us doing support of the equipment is just all our remote access. We can first, you as a customer or you as an equipment operator have remote access to your own equipment. So you can run it from your phone, run it from a computer, run it from a tablet. But then we also, as a manufacturer, have access to that equipment. And that means that if you ever run into an issue, we can log in, we can go back to your data log and see exactly what happened when you had an issue.
When the issue started.
Yeah.
How to fix it. We can live, as we're on the phone with you, we see the screen you're looking at. We could coach your employee through the problem solving method need to be done, or even remotely fix the problem on our own.
Yeah, our support techs, I don't know, maybe 30% of the time while they're on the phone with a customer, they might just go ahead and say, hey, do you mind if I take control for 2 minutes? Also, here, let me walk you through what I'm doing so you can see me do it. And then
if this ever arises again, you'll know how to avoid it.
And so some of the, common problems are, with the ability to run our systems manually, it might be a ball valve was set in manual instead of auto, so that, it had been changed at one point and then it affected your run process. So just the ability, 99% of the problems that can occur are usually fixed remotely within a couple minutes on the phone. And it's just something out of place, from a ball valve being set in manual or a pump being turned off, the air compressor becoming unplugged from the wall.
Yeah.
Little things can happen, but it's super nice for us to be able to remotely see the readout of everything going on and being able to adjust that for you.
Yeah. Oh, here's this is pretty much what we've talked about before, but this is a nice little picture of our remote system. This is one of our support techs running it on a C1D2 phone. But just again, remote access gives you control from anywhere. You can remotely manage your employees from another location. It also gives your employees the ability to monitor the system while they're in other parts of the lab. That wraps it up for us. Did you have anything you wanted to add before we go into Q&A?
No, let's get this started.
Perfect. Great, guys. So we'll pass it over to Adam. Kick off the Q&A section. Now we'll move this camera back so you guys can see both Kyler
How's that?
and Jen.
There we go.
All right, Adam.
Can you hear him?
Adam, you there?
He's talking, we can't hear him.
Oh, that was my fault. Okay, mute on my end, not a connectivity issue that time. Okay, so we do have some good questions here. I've been kind of keeping track, so we'll jump right into it. We got about 10 minutes. The first one is, what certifications do we have in Canada? Do we have the pressure equipment that meets Alberta Boilers Safeties Association requirements?
Yep, we do. So we have, first, all the components on our Canadian system have their own CRN, Canadian registration number, which is a requirement for pressurized piping systems in Canada. And then we also have a separate CRN for the equipment itself. And that, I believe we are in every province.
And we were actually the first BHO extraction company with that CRN approval in Canada.
Yeah, and I think we're still the only one with CRN approval in every province. And Alberta is, ABSA is by far the most stringent of the provinces, mostly because of the strong oil and gas presence. But we have ABSA approval.
Great. All right. And then what are the electrical requirements needed for the IO?
I think the best answer is to shoot an email to one of our sales teams, and they can send you our full installation drawings, just because we've got a lot of electrical components, and it's a lot of detail to get into. In general, off just the top of my head, I think we're at about 140 amps, and everything that we build is 3-phase 240. We have spec'd 480 before, but usually we do 240.
All right. And then what are the dimensions of the IO extractor?
Ooh, I should probably know that. The footprint of the skid is it's about 5 feet square. Yeah.
Right about that, yeah.
Okay.
And then we have, the system comes with the extraction skid itself that sits inside the booth, a control panel that sits outside the booth that typically just bolts to the wall.
So the extraction skid is about 5 by 5.
Yeah.
But then we have the accessory equipment, chillers, water cooling tower, which is, the chillers are probably 4 by 4, 3.5 by 3.5.
And then the water cooling tower is about 4 by 4.
Yeah.
And that gets placed outside your building. Our chillers are water cooled, which is a huge benefit for cooling.
Well, and this is actually the person asking the questions actually up in Canada, so they would have the air chilled units, correct, versus the water cooled.
Yeah, that's correct. Yeah,
Okay.
so Canadian units, we use a different set of chillers in Canada. They're outdoor air cooled, and the footprint's a little bit bigger.
Okay, and they were wondering if it could fit inside a C-can. Could you do a lab, and that's basically a Connex. Would it be possible to do a custom lab into a Connex style?
Yeah, that wouldn't be an issue at all.
Yeah.
Okay, and then what makes the IO a C1D1 versus a C1D2?
C1D1 and C1D2 are electrical terms, so it's all about the electronics that are on the skid. So C1D1 basically means we have different certifications. They're safer than C1D2. So C1D1 is all the electrical components are built to be in an atmosphere that always has explosive gases. The assumption is that they're operating in an explosive atmosphere. C1D2, the assumption is that they could be operating in an explosive atmosphere if something goes wrong. So I think the terminology is like in an abnormal scenario.
And our skid is C1D1.
Yeah.
It goes inside the C1D1 atmosphere and booth. And then we have a control panel that goes outside the booth that is C1D2.
Okay. And then what is the PLC HMI base? Is there a base software that we're using, or is it just all?
Yeah, it's all industrial control software that's specific to the manufacturer of our PLC and HMI. We use Koyo for PLC and automation, WeanTech HMIs. So it's not like programmed in Java or C++ or anything like that. It's a separate industrial control software.
And we do all of our programming in-house. So we're able to change options on the fly, work with the extractors that have our equipment, and can really do everything on the spot within our company.
Yeah, and another benefit to that, just to tap in here as a sales guy, is that if we do have any software upgrades or anything that we come out with on our end, then we can shoot those out to everybody and they can get that update and be running the most advanced version of our software basically as soon as it's available.
Yep.
So I guess in some provinces in Canada, a skilled operator always needs to validate local pressure and temp versus the control system. So how does that work with our system?
I'd have to talk with our operations director and the engineer who's in charge of compliance. He runs all of our Canadian compliance. I'd have to talk with him about it. We haven't run into that I know of. I'm sure it's an easy solution.
Right, and I would think that because we have the availability to have it remote access, you can always tap into it. So you always have some sort of measurement over what's happening in the system.
Yeah. Also, part of our commissioning process, we always do verify vacuum and then atmospheric pressures and temperatures on our sensors before running the system or before startup.
Okay. Yeah, and I'll make sure that I get that info over to the person asking that question. As soon as we get that, I'll have your sales rep reach out to you. So as far as access to the data outside of the HMI, do you have access to the data outside of the actual, and we kind of tapped on that, but someone's just asking.
Yeah, we have a few ways to store it and access it. One is in the memory of the HMI, 2 is in a flash drive that you plug into the HMI, and then 3 is cloud storage. We're working with a couple customers right now to develop the cloud storage, and it's just a more complete analytical suite for data analysis. So not every customer has that yet, but right now everything can be stored to an HMI or a PLC, a USB stick. You can take that USB stick, plug it into your computer, and then you have all the data accessible in CSV form, and you can do whatever you want to it.
Okay. And then what about vibration monitoring? Is there anything that does any sort of vibration monitoring on the system?
No, there's not. Usually vibration monitoring, if I'm going to guess at the intent of the question, it's usually used for predictive maintenance on motors or anything that moves in like a cyclic or anyway, it's usually used for predictive maintenance. We've never had a motor itself fail. So we're not doing any vibration monitoring.
Okay.
We also don't use many motors on the system.
Right. Yeah. It's a lot of it has to do with just pressure differential due to temperature change. So
yeah.
Now, as far as actually operating the system, do you suggest packing the reactor column to its full capacity, meaning packing, 18 pounds of dry or 25 pounds of wet every single run? And I just know personally this changes from lab to lab, and each operator kind of has their own sweet spot. But from your perspective, how do you feel about that?
I'd say, it also depends on how your material is. If you grind it up, you could get the most in, but I kind of like to leave my material more gently packed in. So I'm usually optimizing around 15 pounds dry and 20 pounds wet has been probably what my average is every run. If I'm, only have 25 pounds of like fresh frozen that I'm running, I'll fit the full 25 pounds in and smash it in there. But, you get, you can fit the most in if you grind it up, but if you grind your material up, you can lose a little bit of the color quality because you're releasing the chlorophyll and all of that. So I prefer to pack it.
Yeah, and it's probably, that's one of the great things about our system is that with that data logging, you'll be able to look back and see where your sweet spots are and find that perfect area of how much you put in the bio or into the reactor column, and what your yield is and where you want to be to the quality. So there's a little bit of room for play in there to find what each individual operator and firm is wanting to put out.
Absolutely. So Adam, we got time for maybe 2 more questions, and then we'll let these folks go.
Okay. So we have another question about our chillers. Just who are we going through for our chillers, and what chillers we're using with the system?
We use a few different chiller suppliers. We have like our set units that are water cooled. One is about, to combine, they're about 12 kilowatts at -40 and 10 kilowatts at -60 degrees. They're water cooled. They're fed by a water cooling tower that sits outside. But depending on your installation, we have some customers who'd rather spec air-cooled units. We usually spec only the air-cooled units for Canada, just a little easier. Hard to put a water cooling tower where it's really cold because you got water flowing outside in -40 degree weather. But really
and on our water cooled ones, we actually work with the manufacturer and help engineer and design a lot of the internals, and we get them UL listed here ourselves.
Yeah. So we've been working with that manufacturer for 4 years now, and as we've been going, we've been just doing incremental design changes with them.
And
so
yeah,
really
that's chiller is licensed and only sold through our company.
Yeah.
Okay. And then can the system be chilled down to -60?
Yeah, no problem.
No problem.
Yeah, that's right in the zone, the sweet spot. We can chill to that, and it won't be a strain on the system to me.
And a good thing about our systems, real quick, there's not only can we chill down to that temperature, but we can maintain runs at that temperature, which is really important. That's when Jack mentioned the 7 kilowatts of cooling at -40. We have the power to maintain those cold temperatures, where a lot of these other manufacturers, can your system get there technically if you run it for 24 hours and not under a load? Yes, but can it maintain? Most of the time we're seeing no.
Well, and that also relates to consistency in the output product, because in a lot of our competitors, the temperature that they're quoting is the temperature at the chiller. With us, our temperature is being taken and gauged at multiple points throughout the system and throughout the process. So that's actually the temperature that you're getting and maintaining throughout the entire system. And I think that is another thing that separates the Luna from the competition in terms of consistency of its output, is that what your temperature is, what your pressure is, and you're not guessing about the loss that happens as the process goes through. So definitely keep that in mind with our system in comparison to anyone else out there. Our chilling capacity is really something that sets us aside from the competition.
Right. Throughout the whole system.
Correct. So that's about it. We went a little bit over here, but thank you everybody for great questions.
Yep, absolutely. Awesome. Well, it's been a pleasure to have you guys joining us again here for another edition of Luna's webinar series. Obviously we love taking you, behind the scenes and giving you a look under the hood here at Lunatech. Please stay tuned via email, Facebook, as we continue to start getting out more webinars here in the future. Next up here in January, we're going to be running a Mythbuster episode, which will be a sneak peek on just kind of running our, basically what is true full spectrum. So look for that. We're going to be running it through CO2 equipment as well as hydrocarbon and ethanol. So should be a great one to catch on the next time we get to join you. So from all of us here at Luna Technologies, thanks for joining us, and have a great day.
See ya. Thanks, everyone. Happy Thanksgiving.